Hello and welcome to our Day 8 lecture for Upward Bound Integrated Math 1. Today we're going to talk about, real quick, flashback to last time. We talked about graphing things in slope-intercept form. Today we're going to be writing equations of graphs, and we're going to mainly focus on slope-intercept form. So remember that slope-intercept form is y equals our slope, which we call m, times x plus our y-intercept. And we call that y-intercept b. Not really sure why we call it b or why we call slope m. I know we can't really call the y-intercept y because that's a variable. But yeah, as far as why we use those two letters to denote those words, considering slope doesn't have an m in it and y-intercept doesn't have a b in it, I'm not too sure. But that's just the way the cookie crumbles, I guess. Now, to write the equations, we're going to go over several different methods. For the first one, we're given a graph. For the second one, we're given the slope and a point. And then, if we look past that, I think the last one is when we're given 2 points. So some of them are easy, some of them are a little bit harder. Okay, but let's go ahead and take a look at these. For the first one, if we're given a graph, the first thing we want to do is to find the. I guess I could go either way. But let's say that I want to find my y-intercept. Okay, that's going to be my first step. My second step will be to find my slope. And the third step will just be to write it in y equals mx plus b form. So I will say that this is by far the easiest method of writing equations, or the easiest instance of writing equations, because we've already worked on how to find slope given a graph. Now we're going to have to use that method to write the equation. And all that really goes into that is to find your intercept, find your slope, and then write it in that form. So for step one here, find my y-intercept. It's right here. It's where the graph crosses the y-axis. You might have to do a little bit of work if your graph kind of covers up this number, but this is 4. Okay. The next thing I want to do is find my slope. So I want to find another point to the left or right where this line crosses a true grid point. I will say that this looks pretty dang close. I think this is going to be our closest other point. So in trying to find my slope, I know that I always want to go up or down first, and then go to the right. So I'm starting at the leftmost point that I have marked, and I see that I go up 1 and right 2. So I go up 1, right 2. So my slope is up 1 over 2. And my y-intercept, or my b, is 4. So I get y equals 1/2 x plus 4, as written in y equals mx plus b. There we go. Not too bad. For the second one, my y-intercept is right here. My slope, I can pick a point to the right or left. Let's pick a point to the right this time. I see this point is another true grid point, and that looks like it goes down 1, right 1. So I'll say down 1, right 1. So my slope is down 1 over 1, which we can just write as -1. And then my y-intercept is +1. There's a lot of 1s in this problem. And to write that in slope-intercept form, I get y equals negative 1x, which you may more commonly see that as just negative x plus 1. And there we go. For the next one here, my y-intercept, bam, right there. To find my slope, I think I'll use this point right here. This looks like the next closest grid point. Notice that if I pick the closest grid points as I have here, I never have to reduce my fraction. I will notice that if I mess up and pick one that's not the closest one, I'll get a fraction that can be reduced. There's really no problem either way. But going from my left point to my right point, I'm just going to draw my triangle. 1, 2, 3, 4, and 1. So I do that counting to where I don't have to go back and do it later. But I could have just drawn the triangle and then counted how many times I went up and how many times I went over. So my slope, it went up 4 and over 1, which we just say that's 4. And my y-intercept is at 1, 2, 3. It crosses the y-axis at 3. So my slope-intercept form is going to be 4x plus 3. Okay. Last one here, get my y-intercept right here. It's just where it crosses the y-axis, the vertical dark line. Then I got to pick another point. I think my next closest point is right down here. Okay, let's see what we get when we draw our triangle. I do notice that it's going down, so we'll know that that's a negative. 1, 2, 3, 4, 5, and over 2. So we'd say that's negative 5 over 2. So to write my slope-intercept form, my slope was negative 5 over 2. And my y-intercept again was positive. All these were positive. If my y-intercept happened down here, I would just write this as a minus sign. But my y-intercept's at positive 2. And that's my slope-intercept form. So not too bad. Okay. The issue with these ones is none of them are truly algebraic. They're more actually geometric in the sense that we're kind of using the geometry of the coordinate plane to figure out what the equation is. So these other methods are more algebraic because you don't see a picture along with it. Where you could go and graph a picture. You could do that if you had some graph paper or something like that. What I'm going to do is I'm going to go over an algebraic method. So I remember that in slope-intercept form, I only need to find 2 things. Okay, I only need to find 2 things. One of them is my slope. The other one is my y-intercept. And we'll notice those are the 2 things that I'm finding throughout all these problems. Well, in these types of problems here, I've given you the slope already. But then I've just given you another point. Okay? That other point isn't going to quite help us yet figure out what the y-intercept is. But, and I have this written as 2 steps. I would almost envision it being 3 steps. But the first step is going to be, I could even see this as 4 steps, I guess. We'll just kind of write it up as we need to. But write as y equals mx plus b with m, or with slope for m. Okay, that's kind of, let's call that like step 1A. And then step 1B will be to plug in the x and y values into the equation. So again, I'm going to write these as 1s and 2s, A's and B's. because I just don't think 2 steps really does it justice. I don't remember what I wrote the first time when I planned this out as 2 steps, but I mean, these aren't really hard steps, I will say that, so it's not that bad. Step 2A, so after I've plugged in my x and y values, let's at least get through that part right now. So step 1A, I want to write it as y equals mx plus b with my slope in for m, so negative 2x plus b. And then I want to plug in my x and y values into the equation. So since my y is negative 3, I'm going to say negative 3 equals negative 2. Oops. That needs to be a negative 2. Let's just rewrite all that. Negative 3 equals negative 2 times 6, because that's what x is, plus b. Now keep in mind, I need to find m and I need to find b. I already have m, so I really need to find b. And what I've written here is an equation with only one variable, and that variable is b. That's what I wanted to find. So what step 2A is going to be, and I'll just preface this with step 2B is going to be really easy. But step 2A is solve the equation for b. And I want to solve that equation for b, and then step 2B, write it as y equals mx plus b. So what I'm left with here is an equation that involves b. I want to solve for that. So we'll say I need to multiply first, so negative 3 equals negative 2 times 6, which is negative 12. And then I can add 12 to both sides. When I do that over here, I get 9. On this side, my b's cancel, so I get, or sorry, my 12's cancel, so I get b. And so I've solved it for b. So my y-intercept, or b, in this problem is 9. So I'm left with all this that I had up top, and I'm just going to replace the 9 with b. My slope is 2, my y-intercept, sorry, my slope is negative 2, and my y-intercept is positive 9. So we get y equals negative 2x plus 9. And there we go. Let's try that on this next problem. I have a slope of 1/3. So I'm going to write it with my slope, 1/3 x plus b. Plug my point in, plug my x and y's in, and I get 2 equals 1/3 of, in this case, negative 3 plus b. Now this could be some hard calculation, but in this one it works out pretty nice. Negative 1, or sorry, 1/3 times negative 3 is just negative 1. So I get negative 1 plus b. In order to solve that for b, I add 1 to both sides, and I get b equals 3. So my equation, y equals 1/3 x plus 3. And that's my equation. So notice that we plug in x and y at one point to figure out, we use one case of an x and y. There's a bunch of points that they could have given us. All the points on this blue line would make the two sides of this equation equal, but we have a missing piece. We have a missing y-intercept, so that's why we plug in those values and solve for that b to figure out what it is. Okay. Next, similar problems. We want to do the same thing here. I want to say y equals negative 4x plus b. And then I want to plug in my 3 and my 1. 3 goes in for y. 1 goes in for x. And when I do that, I get negative 4 times 1, which is negative 4. And to solve this, I'll add 4 to both sides. 3 plus 4 is 7, so my y-intercept is 7. And that's my equation. This one I've got a slope of 1/2. We're going to say y equals 1/2 x plus b. And plug in my values here. I have 5 equals 1/2 times 2 plus b. 1/2 times 2 again is just going to be equal to 1. So here I have 5 equals 1 plus b. When I subtract 1 from both sides, I get 4 is my y-intercept. So again, I found my slope, I found my y-intercept, and we can write it in y equals mx plus b. Now again, I will say that it did work out in all these problems that my y-intercept was positive. If it was negative, I would just switch this to a minus sign instead of a plus sign. So be aware of that. Kind of a, not great thing that all of them turned out that way, but it's okay. The last version of this problem is when we're given 2 points. So if we're given 2 points, the first thing I want to do is to find my slope. Okay. I want to find my slope using my slope formula, which I'll write again in a second. So I want to find my slope. Step 2, I want to find my y-intercept using the method above. So using the last section's idea of how to find the y-intercept. And then step 3, write it as y equals mx plus b. All right. The slope formula that we need to remember is my slope when given 2 points, y2 minus y1 over, now that somehow looks like a y8 or a u8. Let's go ahead and try that again. So y2 minus y1, all that over x2 minus x1. So there's a little bit more. Again, this is an algebraic method to find your slope-intercept form. And there's a little bit more work to do here because we have to start off with this nasty formula to find slope and then do all the steps that I just did before. So for the first one here, I want to find my slope. Actually, let me switch colors again. Let's go green. Let's go x1, y1, x2, y2, and for my slope, y2 minus y1, so 6, minus a negative 2 over 2 minus a negative 1. 6 minus negative 2 turns into 6 plus 2, which is 8. 2 minus negative 1 turns into 2 plus 1, which is 3. Okay, so I get to the same case that it was in the last problem, or last set of problems, where now I know my slope and I know a point. I actually know 2 points, so we'll talk about where we get to use that in just a second. So y equals 8/3 x plus b. This is kind of a nasty problem with the 8/3, and it all kind of depends on, from there you can kind of decide which point you want to use. Just making sure I did everything right so far. Yeah, I think we're good. But yeah, like I said, it's kind of an ugly problem. It's doable though, it's just going to take a little bit of work. I'm going to pick the second point because everything's positive. Yeah, I know I get a little bit bigger number that I'm working with, but I can handle that. I don't really like dealing with all negatives. So here we have 8/3 times 2. I'm going to write that as 2 over 1, just as a fraction to help me multiply my fractions. Plus b. Multiplying fractions goes straight across, so I have 8 times 2, which is 16, over 3 times 1, which is 3. So I have 16 over 3 plus b. And I'll subtract 16 over 3, which isn't a great thing to do, but it's still doable. If I think of 6 in terms of threes, that would be 6 times 3 is 18. So that would be 18 over 3 minus 16 over 3. So what started out as kind of an ugly problem will actually simplify to something okay. It's not great, but it's okay. I have common denominators. 18 minus 16 is 2. And the denominator stays. So I get 2/3. That tells me b is equal to 2/3. Okay. Again, not the prettiest problem, I know. There might be a typo in there that I messed up on something that would have made life a little bit easier, but we deal with what we've got. You think this is a tough problem to find the answer like this, it's actually a tougher problem to graph that. So I'm not asking you to graph it, just asking you to find the equation. All right. For the next one, let's pray it's a little bit nicer to us, but we'll see. For my slope, let's go x1, y1, x2, y2, and let's find our slope. -1 minus 4 and 5 minus 1. It doesn't look too much nicer yet, but let's wait and see. -1 minus 4 is -5, and 5 minus 1 is 4. So that's my slope. Awesome. Yeah, it's another tough one a little bit, I guess, but that's okay. We're only getting better at it by doing the tough problems. So -5 over 4x plus b. And again, pick a point. I kind of like this 1, 4 point. It makes life a little bit easier. Here's why. When I plug in 4 there, that's all well and good. But when I plug in 1 over here, I'm multiplying by 1, which doesn't change anything. So I don't even really have to write that. Okay. Now we're going to add 5/4. So looking at 4 in terms of force, that's going to be 16/4 plus 5/4. 16 plus 5 is 21. And I leave my common denominator of 4 on the bottom. So my y-intercept is 21 over 4. If you wanted to be, kind of cheap, I guess you could go to decimals. But over here, if you went to decimals, you'd get some ugly decimals. Here, at least the denominator's 4, so there's pretty easy options for decimals on those ones. But I would prefer that we go with fractions. The reason for that, when I'm graphing these, if I were to ask you to graph these, a fraction as your slope is much better than a decimal. So here we get -5/4 x plus 21 over 4. That's our answer. Okay. Looking at the next one, again, we're only going to pray that it gets better. We'll see. X1, Y1, X2, Y2, and let's find our slope. 7 minus a -3, and -3 minus 2. 7 minus a -3 turns into 7 plus 3, which is 10. -3 minus 2 is -5. Oh, there's one that's okay. 10 over -5 is -2. So my slope is -2 on this one. That's not bad. Should be able to work with that. -2x plus b. And I'll pick a point. Maybe we'll pick the first point. There is a negative in there, but the numbers are a little bit smaller, and that makes life okay. So let's go -3 equals -2 times 2 plus b. And -2 times 2 is -4 plus b. And we add 4 to both sides, which gives us a b of 1. That one worked out real nice. So -2x plus 1. And for our last one, we're just doing the same thing. Nothing's different. But the more we get to practice this, the better we're going to be. That's a 2, by the way. Doesn't really look like it, but oh well. For this one, we get 4 minus a -5 and 3 minus 0. That's going to be 4 plus 5, which is 9. 3 minus 0 is 3. So we get a slope of 3. Again, should work out pretty nicely from here, but we never know. 3x plus b. Plug in, I don't know, maybe we use this one right here. I kind of like this one because there's a 0 in it. -5 equals 3 times 0 plus b. 3 times 0 is 0, so we just have -5 equals b. All right, so here we do have a negative, so we can write that in. It's actually the first time we've had a negative y-intercept today, which, again, not great planning, but so instead of saying plus b, in this case, I'm going to say -5 because my y-intercept is -5. Now, here's a trick with this problem. Where do you see that -5 showing up before we found our y-intercept? Well, it's right here in this point. Anytime I have a point that has 0 for the x, think about where that is on the graph. If I think about the graph, and 0 for x means to start, I don't do anything left or right. In this case, I just go down to -5 and put a point. Well, that makes that the y-intercept. Wherever this graph goes, well, that would have been a lot better if my second line went through the point. Wherever this graph goes, -5 is going to be my y-intercept. So I actually did a lot of work, and I didn't really need to. I could have really been done kind of right here if I would have noticed that this was my y-intercept. It's a little trick. If you don't think you feel comfortable with that trick, do the work. It didn't take much. When we plugged in the point, we got 0 as the x, and that just multiplied something by 0, so it just went away. Not a bad thing to go through that extra work, but if you can catch it early and know that on a problem like this, well, I have my y-intercept right here. This right here tells me that b equals -5. Okay, that's what that tells me right there, that b equals -5. So I don't have to do any work after finding the slope. I still had to find the slope to get this 3, but afterwards it would have been a lot easier. Okay, not a big deal if you don't remember that. Like I said, you can always just go through the work, and it might take you a little bit longer, but it's still going to get you to your end goal. That being said, good luck on the practice, and stay tuned for the application walkthrough. And good luck. We'll see you next time.